What questions about the Java Collections API you are very likely to be asked on any Java software engineering interview? Hi guys, welcome to my channel. My name is Vitaly. I'm a lead software engineer in Los Angeles, California, and today we're gonna discuss with you Collections API. So the Collection API is probably the most popular topic on any Java software engineer interview. So in case if you're preparing for the interview or you're planning to kick off your career as a Java software engineer anytime soon, make sure to watch this video till the end because I'm gonna walk you through all the popular questions and answers. And by the way guys, if you want to see more programming content from me like this in your recommendations, make sure to hit the subscribe button down below and ring the bell. Alright, so the first question is, what is TreeMap? What is the underlying data structure of the TreeMap? And how we can use it? What are the real use cases for this? So the TreeMap is the type of collection, or to be precise, it's a map, one of the implementations of the map, that allows you to store all your keys sorted in the appropriate order. And we usually define the sorting order by implementing the Java interface, which is called comparable, or we can also provide the sorting order by ad hoc providing the implementations of the comparator interface, so that we can tell exactly how we want our keys to be sorted inside the collection. So for example, if you would have the key value pairs in your collection, which are also known as entries, and the key would be the integer, and for example value would be also integer. But we do not care about the value much. Let's discuss a little bit about the keys. So by implementing the comparable interface or by providing the ad hoc implementations of the comparator, you can tell exactly how you want your keys to be stored and sorted inside the TreeMap. So you can already imagine what kind of use cases would be for the TreeMap. The TreeMap would be useful in case, again, if you want your keys to be sorted in very specific order, and for example, you need to do the iteration over your keys to figure out some information, or maybe you want to aggregate some information from your map, from the entries that exist in your collection. So in case if you'd use the TreeMap, it would serve all your needs regarding the sorting of the keys, and you would not have to do anything yourself to resort them or probably to care about the order, because it's going to be done for you automatically under the hood. So to extend your answer or to show the interviewer that you know even more, you can talk a little bit about the underlying data structure. So you can tell the interviewer that the TreeMap is based on the red-black tree. And red-black tree is not only showing the good performance for the common operations like put the element or get the element, but it also known for its ability to rebalance itself. Meaning that if it can rebalance itself, you don't have to care about anything about the sorting or rebalancing or anything else. It would do all your work for you. So at any given moment of time, you can be sure that your keys will be sorted. So the next question is, how does HashMap ensure the constant access time complexity in the best case? So this question really checks the understanding of the person what is happening under the hood. So first of all, we need to say that the HashMap is essentially based on the array. And array usually stored at the whole block of memory, and it means that any given moment of time, the program can understand where to get the particular element of the array. And for that reason, accessing an element of the array by index is a really fast operation. So the HashMap uses the array as an underlying data structure, but it also uses the mechanism of hashing under the hood. So when we put the key value pair inside the HashMap, HashMap is gonna call the hashCode method of the key object. And as we know that the hashCode method is extended by the object, meaning that each object in the Java would have this hashCode method. And we also know that the hashCode usually calculated by the unique characteristics of the specific object. For example, based on the values of the fields, meaning that two different objects should produce two different hashcodes. And once the hashcode has been calculated, the HashMap is going to apply the special algorithm that can translate the input hashcode to the particular index of the array. And in terms of the HashMap terminology, this kind of index of the underlying HashMap array is usually called bucket. So once the index has been calculated based on the hashcode, and we know the index of that underlying array, the bucket essentially, the HashMap is going to put the key value pair to that index of the array. And each time when you would try to access your value by providing the key, it would do the same kind of operation. It would again call the hashCode method of the passed object, where you pass it to the get method of the map. it's gonna try to calculate the hash code. It's gonna again apply the same kind of algorithm to figure out the index of the underlying array, the bucket, and it would try essentially to access array by index, and in case the element was found, it's gonna return you with the value. If the element was not found, it's gonna return you the null. So that is why it works really fast, and this is how we answer and how we can ensure the constant access time. It is happening because we are using the array as an underlying data structure in the HashMap. And the calculation of the hash code and transformation the hash code to the index of the array to the bucket is a really simple operation. And once we know the index, we just do the operation of accessing element of the array by index, which works really fast. So the next question is, why do we need to override the equals and hashcode methods of the object if we want to store this type of object inside the hash set or the hash map? So probably at this point you can already guess why do we need the hashcode, because the hashcode is the method that can transform the specific properties of your object to the integer value. And this integer value would essentially represent the unique number of your object. And this hashcode will be used by the hash map to do the transformations of the incoming number to the particular index of the underlying array, which we also know it is called bucket. So to discuss further why do we need equals in this kind of chain, we need to firstly say that the hash set uses the hash map under the hood, and if you open up the implementation, you would see that there is a composition, and hash set would essentially contain the hash map, and this hash map would just use the key as the element that you just added to the set, and the value would be the dummy value, just in order to reuse all the functionality of the hash map. So as we already know that we're gonna work with the array for storing all of our elements, and when two different objects with a two different hash code would result in the same index of the underlying array, it is also known as collision. We're gonna discuss the collision situation a little bit further in this video, but essentially it's just this kind of mismatch. And we have essentially two cases. So for example, you already have some value present under your specific index, under specific bucket, and you're adding the new element that also resulted in this kind of index of the bucket. And at this point, the hash map would try to compare the keys that are already stored at the key that you just added by using the equals operation. And that's why we need to override the equals operation, because we need to be able to correctly compare the objects. So in case, if by comparison the keys that you just added and the key that already presented in the map, it would result in true by equals, it's just gonna replace the key value pair in your collection. But in case it would result in false, it would actually mean the collision. And this is a bad situation, it's gonna slow down the performance of our map. But in case if you do have the collision, we need to still store somehow the elements. So it would add the new key value pair to the same kind of bucket, but it's gonna be the second element of that bucket. So essentially you would have an array, and each element of that array will be represented as a linked list. And it's a technically possible situation where all of your objects that go to the hash map would result in the same kind of bucket, and you would essentially have not the hash map, but instead the linked list. So your worst performance, if all your elements would result again in the same kind of bucket, would be linear. It would result in the linear time complexity. But as a summary, we can say we need the hash code to define the appropriate bucket in the underlying array of the hash map, and we also need equals to correctly compare the keys and figure out whether it's a collision, and we need to add that element under that same index, or in case if the items are similar, we're just gonna replace the entry. The next question is, what is the difference between ArrayList and LinkedList? So both LinkedList and ArrayList, they implement the interface which is called list, and lists usually define the method that would allow you to work with your elements inside the collection. For example, like getting the element by index or adding the elements to the collection. And by looking at the name of those implementations like ArrayList and LinkedList, by name you can already guess what is the difference between them. Because the ArrayList uses the array as an underlying data structure, meaning it would have the same kind of benefits and drawbacks that array does. For example, if you want to insert the element on the specific index, or you want to, for example, access your elements by the specific index. This operation would work extremely fast because as I told you before, the array usually stored as a whole block of memory, and your program already know where to find and where to look up for all your elements inside the array. But also we have the drawbacks. For example, if you want to insert the element in the middle of your array, it would mean, in case if you don't have enough capacity in your current array, you would have to copy all of your elements to the array of the bigger size. And also you need to shift all your elements to the index +1 position, the elements to the right, to actually have that space where you would insert your newly added element. And as you can guess, this operation can be extremely slow. Imagine you have a really big array, like millions of records, and you just added the new element and you don't have enough capacity. So to do that, you would have to clone all the elements of this 1 million array to another array with the bigger capacity, shift all the elements, and then just put your newly added element. And it's only for one operation. And imagine if you would have like thousands of such operations. Of course, it's not going to be that effective. So in that case, you can leverage the linked list. And the linked list is basically based on the linked list data structure. And it would mean that all your objects can be randomly placed inside the memory, but they are connected to each other to the actual list by using the references. But they can be absolutely randomly located in your memory. And due to this, we can already assume what kind of benefits and drawbacks we can get out of the linked list. So for example, if you would need to add the element inside the middle of your linked list, it's going to be a really easy operation because all you need to do is just to swap the references to look at your newly added element and you're done. This operation would be extremely performant. But the drawbacks of the linked list, in case if, for example, again have the linked list of 1 million records, and imagine you would need to get the last element inside your linked list, so you'd have to actually pass all your elements on the linked list because you don't have such kind of index or your program don't know where the object exactly placed. So you would have to walk through all the elements to find the last element to return it to the client. And in case you have the requirement that you need to really quickly access all of your elements, of course the linked list would not be like a suitable case for you. You can leverage ArrayList instead. And as a summary, we can say that we can leverage ArrayList when we want to have the same kind of benefits as for array, like quickly access by index or replacing the elements on the particular position, and instead we can use the linked list when we want to have the good performance for the insertion operation, for example in the middle of your linked list. But also, by extend this answer and show your proficiency even more to the interviewer, you can say that this kind of operation, when you clone the elements of your current array to the array of the bigger capacity, in case if you want your underlying array inside the array list to become bigger, this kind of copying operation will be executed by a method which is called array copy. And this kind of operation of copying the old array to the new one with a bigger size will be implemented by using the array copy method, which is implemented as the native method in Java. And as we know that native methods in Java mean that this particular method was implemented on a different programming language, and usually it's lower level programming language that would give you more benefits in memory manipulation like C or C++. So array copy work extremely well. And I would say from my personal experience that in most of the cases you would use the ArrayList. The next question is, you have a string and you need to know whether the particular strings belongs to the collection of the strings, which can be huge. What would be the optimal collection to use to do this kind of contains operation? So to answer these questions, you need to again know what is happening under the hood. Because regularly people would use the array, for example, to store all the elements and then would just do the contains operation. But imagine you have like 1 million elements inside your array. In the array, there is no possible way to quickly check whether the element is already in array or not. And so, meaning if you want to check your string belongs to the array or not, you would have to walk through all the elements to check whether it's there or not. So in the best case, you would find it in the first position, and in the worst case, you would find it in the last position. And as you can see, the time complexity for this would be the linear, and it would increase with the amount of elements that present in your array. So we can tremendously increase this kind of contains operation performance if you, for example, would use another type of collection. For example, the hash set would be the really good data structure over here. For example, as we already know that the hash set uses the HashMap under the hood with the dummy values and the key as your element that was added to the hash set. And it is gonna do pretty much I already explained before for the get operation, but it's gonna do exactly the same for the contains operation. So in case if you, for example, don't have the collision inside your hash set, inside your hash map, when you want to test whether your element is already present in the hash set or not, it's gonna do the contains operation. And this contains operation for the hash set is gonna again try to get the hashcode by executing the hashcode method of the passed object. And once the hashcode integer was generated, it's gonna apply the same kind of algorithm to figure out the bucket. And it would essentially just try to get the element by the index because it already knows the exact index by calculating it based on the hashcode of that value. And in case if it would result that something already present under that bucket, and the equals operation of the element that is passed to the contains method and the element that is already stored would result in true, obviously contains would also result in true, meaning that your element already present inside the collection. If it's not, obviously it is not present inside the collection and contains would result to false. But this operation will be extremely performant in comparison with, for example, traditional lookup through all the elements. Because all it does is just calculate the hash code, transform it to the index of the array, and try to access the array element by the index, which is the constant time operation. So it would work extremely well. So the short answer, if you want to have the performant contains operation, put all your elements into the hash set. So another question is, what is Deque and what are the real use cases for the Deque? First of all, we would need to tell to the interviewer that the Deque is essentially the double-ended queue. And the double-ended queue means that we can access the element from both directions. For example, when you're using the regular queue, you would usually have the same kind of order as in a regular queue, for example, in the grocery store, where you put the elements from to the one side and you access the elements from the other side. And this kind of data structure as queue, also known as FIFO, first input, first out. And on the other side, we also have the stack, which is also known as LIFO, last input, first out, where you can access all your elements from the same side where you put it. And by using Deque, you can pretty much organize the stack, the queue, or you can organize the mix where the element will be accessed from both directions. So the real use case for using the Deque would be any algorithm that you would potentially use with stack or queue. For example, for queue, it can be organizing the message bus. And for the stack, it can be, for example, the string validation, or for example, traversing the binary tree. So as a summary, we can say that the Deque is a double-ended queue that is mixed between the queue and the stack, and the use cases for the Deque are the same as for queue or the stack. So the last question that we got is, what is the collision inside the HashMap? So I guess I already briefly covered what a collision is. It's, for example, when two different elements that you put inside the HashMap, it would produce the different hash codes. But for some reason, after applying the HashMap algorithm to figure out the bucket where to put all your elements, it would result in the same array index that will be used to place your key value pairs. If you, for example, already have the element on the specific array index and you put the new key value pair and the key would generate the hash code, and by applying the algorithm of the HashMap, it would result the array index and it would try to put your newly added the key value pair under that index. But there is already a stored element there. It would compare it by the equals method and it would result in false, and this is technically collision. And it would try to add the elements to the end of the current array index, and technically it would mean that your underlying HashMap array would become the array of linked lists. And in the worst case, all your entries that you put into your HashMap would generate the same kind of bucket, and meaning that all your elements will be added to the same array index, and it would essentially create a really long linked list at that index. So that once you try to access the element by key, for example, not only it would figure out the particular bucket, but it would have to go through all the elements and try to do the equals operation with all the elements stored in that linked list to find your element. And you can already guess that it would tremendously slow down the performance of our HashMap and essentially transform it to the linked list. So it is our responsibility as a developers to override the hashcode method correctly so that you would have the good distribution of your key value pairs across all the items of the array, and it would give you the really good performance. And in that case, for example, as we discussed on the first question, it would give you the constant time access operation. But it's great that usually all the modern IDEs like PyCharm, IntelliJ IDEA, or WebStorm or VS Code would have the function that can generate the hash codes for you, so you don't have to worry much about the hash code generation. Just make sure that always include the unique fields for the object so that it would give you this kind of hash code distribution. And there are also popular libraries that can generate the hash code for you, for example, like Apache Commons or Guava, and you will see them in your production projects really often. So this is how you would answer the question regarding the collision. And just to again show even more level of proficiency to the interviewer, you can say that in case if there are many collisions inside the hash map under the specific index of that underlying array, the hash map would try to do the optimization, and after the passing the threshold of the elements under that specific index, it would try to restructure the linked list to the tree to give you a little bit better performance. So these were the most popular questions about the collection API that I got from my personal professional experience, and there is a very high chance that you would have some of them on your job interview. So in case if you enjoyed the video, make sure to hit that thumb up icon. It would tell the YouTube algorithm that this video is good and it would promote it better. Simple action for you, but good result for me. And I'll see you in the next videos. Bye!